Good morning, students. So today's class we are going to detect the QRS complex from the ECG signal. So there are different techniques are available. The first method is template matching method. So under that we have template cross correlation method as well as template subtraction method. And the second method is differentiation based QRS detection technique. So in that we have simple high speed QRS with detection algorithm and high speed QRS with detection algorithm. So first let us study about the template cross correlation method. So here our aim is to detect the QRS complex from the ECG signal. So we have to eliminate the that is in the ECG signal we have to generate a template. So the template will be like a shape of a QRS complex. We know the amplitude of the QRS complex and the time period. So with the time period and amplitude as an input, we have to develop a template for the QRS complex. So after developing the template, we have to place the template over the ECG signal and then perform cross correlation. So while you place the template over the ECG signal, so first you will be placing the template over the baseline. Before the P wave, you have a baseline. In the baseline, you will be keeping the template and perform cross correlation. Then the template is moved towards the P wave. Then the template is moved to the P wave and then you will be perform cross correlation. Then the template is moved from P wave to the next baseline next to the P wave and then it is moved to the QRS complex. Like that the entire ECG signal, the template will be moved, and then each time when the template is kept over the signal, the cross correlation coefficient is calculated. So while you're calculating the cross correlation coefficient, the cross correlation coefficient always falls between the value +1 and -1. So if the correlation coefficient is near to +1, it indicates that the signal and the template exactly match. So if the correlation coefficient is -1, so we can say that the template and the signal it does not match at all. So the QRS complex is detected mainly based on the correlation coefficient which is attained. So if you see the correlation, cross correlation form expression, mathematical expression, it is denoted by Rxy of m. So which is equivalent to 1 by n summation n equal to 0 to n minus m minus 1 x of n plus m y of n for m varies between 0 to n minus 1. So we can also write this equation in other form. So in first one we have represent x of n plus m y of n. Second equation we can express it as x of n y of n plus m. So either x of n can be moved with respect to m varies between 0 to n minus 1 or y of n plus m here it can be moved which varies between the limits which is given here. Then we can calculate the cross correlation coefficient by using the formula rho xy of m equal to r xy of m divided by the square root of summation n equal to 0 to n minus 1 x square of n into summation n equal to 0 to n minus 1 y square of n. So we can calculate the cross correlation coefficient by the cross correlation function divided by the individual square root of individual signal square. So using this formula, we calculate the cross correlation coefficient. Now, if you see the signal, the first signal represents the ECG signal. Second one represents the QRS template. Now, this QRS template will be placed over the first initially baseline and then over the P wave and then over the QRS complex and then it will be moved to the entire signal. So now, when you keep this QRS complex over this baseline, and then perform the cross correlation and calculate the correlation coefficient. So definitely we can say that the amplitude of the baseline is 0 and the QRS amplitude is different. So when you multiply with this and perform the cross correlation, definitely it doesn't match. Then the template is moved over the P wave. When you perform the cross correlation coefficient, definitely it does not near to +1. So now the template is moved over the QRS complex. When exactly this template is placed over the QRS complex, then it will match. So we can get the correlation coefficient as +1. Then it indicates that the signal and the template exactly match. So like that the process is repeated in this template cross correlation method. The next method is template subtraction method. So what is the difference between the template cross correlation method and template subtraction method is in cross correlation we'll be placing the template over the signal and perform cross correlation. Whereas here in this template subtraction method, we used to subtract the signal. So that means we are going to place the QRS complex over the signal and subtract each point and finding out the difference in value. If the difference in value is close to 0, then we can say the QRS complex is aligned with the template. So if we have non-zero values, so then we can say that the template and the signal doesn't match at all. So based on number of such zeros, we can able to measure the QRS duration. So the advantage of the template subtraction method is the operation of subtraction is very simple process. It does not, if it is a cross correlation, means we have to perform shifting, then multiplication, summation. So these operations are not at all involved in the subtraction process. It is a simple subtraction process. That is the main advantage of this template subtraction method. The disadvantage is the signal should be free from noise. Only then we can apply these techniques. If the signal is having some noise, in that case, if we apply this technique, it won't work. So the signal to noise ratio is need to be very large, and the signal should be free from any baseline bantering effect or any artifacts. And then here the considerable amount of pre-processing of the signal is required. So if we are not pre-processing with the noisy ECG signal, we can give as an input to this techniques. It is difficult to extract the QRS complex from this method. So that's why the signal should be free from noise if we have to apply this template subtraction method or this template cross correlation method. Thank you.